Hi and welcome. In this video, I will walk you through how to use the OpenSSF CVE Benchmark for AI, a benchmarking framework that helps you compare the performance of traditional static application security testing tools and AI-based analyzers on real-world JavaScript vulnerabilities. Whether you are a security researcher, tool developer, or just curious about how AI performs in static analysis, this video will help you get started. We will go over the prerequisites, how to download the dataset, run the integrated tools, and evaluate your own tool using the same benchmark setup. Let's get started. The benchmark includes 4 integrated tools: CodeQL, DevSkim, ESLint, and NodeJsScan. You can run the benchmark yourself and generate results with these tools, just follow the instructions in the README. But to save time, we have already uploaded the results to Zenodo. I'll show you how to download and use them in this video. Head over to the README and click the link to Zenodo. Scroll to the bottom, then click Download. Once the archive is downloaded, extract it into a folder called Work. Inside you will find 2 directories: Results, which holds the tool outputs, and Sources, which contains the projects from the dataset. Now move the Work folder to the root of the benchmark project. If you haven't cloned the repository yet, go ahead and do that now. Once you have the repo, drag the Work folder into its root. And that's it, the dataset is ready. Next, we will initialize the benchmark environment. Run the script called init benchmark. This downloads the Docker image with the benchmark's code, all the necessary packages, and everything else you will need. It takes a few minutes, but you only have to do this once. During setup, it will also check if the results are in the right place. If you see messages saying that tool results exist, that means everything was detected correctly. Now let's view the results from the traditional tools. To do that, run the report-based script. The benchmark will start generating a report. This takes a few minutes. Once you see server is running on localhost port 8080, you can open the report in your browser. Either type the address manually or just click the link in the README. After a few seconds, the report will load and you will see the results. Before continuing, be sure to stop the running container. This frees up port 8080. Alright, now let's try using your own AI model for analysis. We have built a reference analyzer for this, and you can easily replace the built-in model with your own. There is a full guide for that in the OSSF SAST-ML repository. In this video, we will use a simple random guesser implementation just because it runs faster, but the process is exactly the same for your own model. The easiest way to integrate your model is by modifying the install script of an existing tool. Go to the contrib/tools folder, then open the install.js file from the installers directory. If you have forked the model repository, you can change the git clone URL here. But in this demo, we will just check out the random guessers branch. Next, let's say you want to add another AI tool. Start by creating your own version of the tool using your model. Then, duplicate our existing tool folder in the contrib/tools directory. Rename the folder to whatever name you would like to see in the report. For this example, we will call it randomguess2. Also, rename the corresponding .ts file in the src folder. And don't forget, open that .ts file and update the tool_dir variable to match. These 3 names, the folder, the .ts file, and the tool_dir value must all match, otherwise the benchmark won't recognize your tool. Now open the runner script and add your new tool to the tools variable. Use semicolons to separate multiple tools. We are ready to build and run the benchmark with your custom tools. Run the build, run and report script. This will build your tools, run the analysis, and generate the updated report. We have sped up the build process in this video to save time. When the script starts, it checks if results for the traditional tools already exist. If so, it keeps them. Then it starts analyzing with your custom tool, in this case the random guesser. We have sped up this part too. Only the first 20 and last 20 projects are shown in real time. The total analysis time depends on your model. The benchmark itself has very little overhead, as you can see, just a few dozen to a few hundred milliseconds per project. When the first tool finishes, the second one starts analyzing. Same process, same speed up in the video. Once all tools have finished, the benchmark generates the final report. As before, wait for the message, server is running on localhost port 8080. Now you can open the report in your browser. The report is generated after the page loads, so it may take a bit longer than before. When the results appear, you will see your newly added tools in the last two columns of the report.